Hello. Hello, hello. How are you doing? Hi. Can you do, can you do private message only today? Or can you still send it to everyone? I'm not sure. How's it going? Are you all good? Did you find this paper all right?
All right, so welcome again. Welcome again. Thank you for coming. Well, I really do appreciate that. You two are being very punctual. Hello. Oh, so you can send it to everyone. Nice, nice. I think I finally understand how to make it work. I finally figured out. So thank you for being so punctual. Thank you. I'm not sure about the others, but you two are definitely, wow, really hardworking and have a strong desire for these, you know, like more challenging questions as well. I really do appreciate that. That's really nice. So we will be starting in 3 minutes, which is exactly 7 p.m. sharp. Okay. Let's just wait for a little bit. Wow, you were just doing homework. Wow. Have you got many homework? Like a lot of them? I see. I see. Wow. I guess homework is not always bad though. Definitely. Because it's going to be good practice for you, right? It's going to be good practice. So, of course, homework is important, definitely. I know it's sometimes pretty painful to be finishing all those homework, but it's pretty useful and it's good for you. Okay. Hello. Hello, those who've just joined. Amber, Leah, Sophia. Hello. Welcome. Welcome to the session again. Wow, I really do appreciate that. I mean, it's very noble of you to have the passion of studying on a Friday night. So first of all, I need to give you a round of applause, and to yourselves as well. Ah, I see. In Spain, all right. Yeah, I do appreciate that. It's almost 7. Yes, we are starting right at 7. So it's 7 o'clock. Wow. I probably need some water. It's 7 o'clock now, and we are just about to begin with this lesson. So I hope you're all ready. I hope you're ready. We are starting with a pretty small group today with only 7 of you in the classroom. So it's almost like one of our day-to-day lessons. Why? I'm not sure. I'm not sure why. Probably your counterparts, they're just a little bit, you know, feeling lazy on a Friday evening, but that's totally understandable. That's totally understandable. Maybe they're just going to join soon. Maybe they're just going to join a few minutes later. I don't know, but let's begin with the practice paper 3 on word problems. Hello, hello everyone. Welcome, welcome. So the first question is definitely about the inclusion and exclusion principles mixed with some number theories. So what it says is that, well, Mrs. Sanders has 3 grandchildren who call her regularly 1 quarter every 3 days, 1 quarter every 4 days, and 1 quarter every 5 days. It says that all 3 quarters on December 31st of 2016, which is the last day of the year, right? Definitely. And it is asking that on how many days during the next year did she not receive a phone call from any of her grandchildren? All right, so that's the question. That's the question. On how many days during the next year does she not receive a phone call from any of her grandchildren? So we can just try to think about this problem as an inclusion and exclusion problem, which is, like a little bit like a Venn diagram. So if you draw a Venn diagram with 3 circles, you can see that, well, say this is the days which are divisible by 3. This is the days that are divisible by 5. These are the days that are divisible by 4. So we have 3 circles. And definitely for these 3 circles, there are some overlapping parts, right? There are some overlapping parts. And now we need to think about one thing. So how can we calculate these? Like how many numbers are in these circles? For example, do you know how many days are divisible by 3? In 365 days of the next year, how many of them are divisible by 3? If you just list all the 365 days from 1 to 365, yes, definitely, that's right. So for divisible by 3, we have 365 divided by 365 divided by 3, that's 121, right? And similarly, we can find those number of days which is divisible by 4. So how many days are there? Why did I write 45? 365 divided by 4, that's 91. Yes, exactly. And also divisible by 5. How many days are divisible by 5? 73. Good. So that is the first step. But you can see that there are some overlapping parts, which means that if I add up all these number of days all together, it's going to be more than the original number of days that Mrs. Sanders will be receiving a call, right? Because some of them are calling on the same day. So if you just add it up directly, it's going to take away, it's going to be counting those as 2 different days or 3 different days, right? So that's going to be more than the number of days it should be, which the grandchildren called Mrs. Sanders. Does it make sense? So that's the reason why we need to remove some of it in the middle, like this bit, the overlapping bit. We need to remove the number of times that it has been repeatedly counted, right? So first of all, we can try to remove this section, and this section. But then what's going to happen? If I remove all these sections, it means that I will be removing this part, this part, this part, and the middle part thrice, 3 times, right? So what it was saying is that, well, so basically, you can see that for these sections, which are like pedals, they are only having 2 circles overlapping on these areas, right? But in the center, like these, like this little thing, it has been counted 3 times, where on the edges, it's 2 times. So if I take away the whole of this, I'll use another color. If I take away the whole of this, and this, like the 3 rugby shapes. Of course, I will be eliminating the double counts on the 2 sections, but I will be repeatedly deleting the middle section, the 3 section, by 3 times, which means that that is 1 extra time taken away, 1 extra time taken away, right? Because I need it to count 1 time, at least. I want every section to count 1 time. So if I'm removing all these 3 rugby shapes, I will need to add back the overlapping bit in the middle, which is like the light blue section in the middle. Okay? So that's what we are going to do next. That's what we are going to do next, which is we are trying to find the number of days where 3 and 5, which are both divisible by 3 and 5. So basically the 2 grandchildren are calling on the same day. The 3 and 5, the 2 grandchildren who called every 3 days and who called every 5 days are going to call on that same day. So now this time we are dividing 365 by the lowest common multiple of 3 and 5, because that's after how many days they will be calling on the same day, right? So it's divided by 15. Yes, that's right. So the quotient is going to be 20. Means that there are 20 days, no, not 20, 24. It means that there are 24 days where these 2 grandchildren are going to call on the same day. And what about for 3 and 4? We just do a very similar thing. 365 divided by, yes, 12 this time. So it's going to be 30. And as for 4 and 5, we'll have 365 divided by 20. That's going to be 18. So we need to remove these away because these are the rugby shapes. These are the rugby shapes. So we don't want to repeatedly count these days, right? But at the same time, when we are removing these rugby shapes, we will be taking away the center 3 times, which means I need to add 1 time back to the whole sum. So I also need to find out what is the rugby shape in the middle. All right. So for the days which are divisible by both 3 and 4 and 5, all of them, how many days are there? This time it's going to be 60. Yes, so it's going to be 6 days. So the calculation is going to be 121, adding 91, adding 73, taking away 24, taking away 30, taking away 18, and adding 6. So that is a pretty clumsy calculation indeed. So can anyone tell me the answer of this? Perhaps not. So you can see that these three adds up to 72, right? So it's going to be 73, take away 72, adding 6, adding 91, adding 121, which is going to be, is it 209? 219, yes, that's right. Carry over, okay? You need to mind the carry over. Okay, does it make sense? So 219, that's the number of days that Mrs. Sanders got called, which means that the final answer is 365, take away 219, which is going to be 146. All right, so the answer is D. Okay. So that's for the first question. That's for the first question. Well, actually, the first question is among the most complicated ones in the whole paper. So don't worry about it if you can't solve it. And also, I didn't say that the first is going to be the easiest. I didn't say that, right? So definitely, like, it's going to be a random mix and match of everything in this paper. Oh, you found question 6 hard? Well, it is a little bit. It is a little bit. And the second question is pretty much interesting. It says that 5 friends are sitting in a row of 5 seats, which are numbered 1, 2, 3, 4, 5. From left to right. Okay. And during the movie, Ada went to the lobby to get some popcorn. When she returned, she finds that B has moved 2 seats to the right, Sissy had moved 1 seat to the left, and D and Addie had changed seats. How long did it take me to complete the question? Good question. I think it's usually about 3 minutes. But for this one, maybe like 1 minute. For the last one, maybe like 3 minutes, because it takes time for the calculation. So of course, it's going to be varying between different questions, right? Oh, the whole paper. Well, I set it, so I didn't really try that out myself. But if it was me, I would say about 20 minutes tops, 20 minutes tops. Nah, I'm not going to solve it in 1 minute. No, I'm not that good. And also, it takes time for me to read the question, right? So of course, it's going to be much more than 1 minute. I might need 1 minute for each question to read it through. No, you're not supposed to. You're not supposed to. Of course, you're not. I was just saying that I can do this in 20 minutes. Well, back to the question. Back to the question. 35 is good. 35 is good. Don't worry. So actually, there's a trick about this question, which is that if A, B, C, D, E are all sitting in the 5 seats, 1, 2, 3, 4, 5. Well, if you add up the sum of their seat numbers, it's going to be 15, right? It's going to be 15. And now, if I'm just treating this as a, number line, each time you move right, it's going to be adding. Each time you move left, it's going to be subtracting, yeah? So it says that Addie and D and Addie, they have changed their seats. So the sum of D and Addie is going to be stable, right? So the 2 numbers for D and Addie is not going to change. But then B has moved 2 seats to the right, which means that the seat number for B has gone up by 2, yeah? Where Sissy had moved 1 seat to the left, which means that the seat number for Sissy has gone down by 1. So how do you think Ada is going to move in order to make sure that the sum is still going to be 15? Because we are starting with 15, right? For all the seat numbers added up. And then the next one is the operation for Ada. What does Ada need to do to still get 15? Yes, exactly, -1, -1. Which means that Ada needs to move to the left by one seat, right? Ada needs to move to the left by 1 seat. And it says that she's left with an end seat, which means that after moving 1 seat to the left, adder is at the very left end. So you can't move one seat to the left and go to the right end. Yeah. So it's going to be the first seat that adder is ending up with. And before, it should be one seat to the right, which is the second seat. Okay. So basically, that's how we solve the second question. Or, of course, you can do trial and error, but that's going to spend a little bit more time. So again, because when you add up the 5 seat numbers, it's going to be 15, right? It's always going to be 15. Does it make sense? And moving right will be adding a number. If you're moving right 2 seats, you will be adding 2 to your seat number. And if you're moving left 1 seat, you will be taking away 1 from your seat number. So that's what B did. That's what B did. That's what Sissy did. So what about adder? I don't know who's your brother. I don't know who's your brother, Yi Chen Shi. I don't know. I probably, oh, Rick? Rick Xu? I think I taught him before. Ah, I see. Yes, I did. I know him. Yes, I know, I remember you. I certainly do. All right. So for adder, adder's moving 1 seat to the left and ends up with the leftmost seat, which means that before, adder's going to be in the second seat. All right. And, well, next, the third question. So again, the third question is very much like the first question. The third question is very much like the first question. It says that altogether there are 20 students, where 10 take part in yoga, 13 of them take part in bridge, and 9 take part in painting. So how many of them should there be altogether? Yes, that's right. There should be 20, but when you're adding these up, you can see that it's 32, which is 12 more than 30, which is 12 more than 20. And now it says that there are 9 students who are taking at least 2 classes. So, well, you're just doing some calculations there to find out how many students are taking all 3 classes. So first of all, of course, you are taking away 20 to find out how many redundant classes, or like how many more classes that the students have taken. How many extra classes have they taken? If 9 of them are taking at least 2 classes, well, first of all, let's find the sum for that, which is 12. If 9 of them are taking at least 2 classes, and well, altogether they are taking 12 extra classes, which means that first of all, I can take away 9 because all of them have done at least 1 extra class, right? So we get 3. And the 3 remaining is the number of extra classes on top of 2. Does it make sense? So like, for example, 9 students are taking at least 2 classes. It means that let's treat them as if they are all taking 2 classes and see who are doing the extra classes on top of 2 classes. So that's going to be 3 of them. So the answer is 3. All right. So this one is not as hard as the first one. It's a bit more manageable. What is the password? What password? I'm not really sure what you are talking about. You need to use the app. I don't think we have a password. Really? Do we have a password? I don't know. Is it 1, 2, 3, 4, 5, 6? Really? Okay. All right, then it's 1, 2, 3, 4, 5, 6 then. Oh. How did you know that? Okay. That's suspicious. Wow. I've again encountered a new challenge for using Zoom here. But yeah, I guess probably what you're saying is right.
On the top left, on the very top left corner, there's a green shield with a tick on it, and then if you click on it, it just gives us all the information about the meeting.
Ah, really? Well, I don't see that anywhere, but okay. If you say that's the case, then that's the case. I'm just gonna trust you with that. Well, that's the fourth question, which is coming up next. Nah, sorry, I've gone through that already, but probably after I've done with everything, I can go back there to, explain it a little bit, all right? Or probably you have to, like watch the playback later, perhaps, but just not now, Maybe I can do it later, all right? So the fourth question, is it the fourth question? Yeah, I believe it is. Last year, Isabella took 7 maths tests and received 7 different scores, each of them between 91 and 100. And after each test, she noticed that the average of the test scores was an integer. So it means that after adding each score, it's always divisible by that number of tests. Okay? And it says that her score on the 7th test was 95. And it's asking you what was her score on the 6th test. So how we crack this question is a little bit like a remainder problem, which is, you know that after adding 95, the first 6 scores will be divisible by 7, where 95 divided by 7 is 1313 with a remainder of 4. So if 95 has a remainder of 4 when divided by 7, it means that the sum of first 6 divided by 7 is going to be having a remainder of 3. That's how you can combine the remainder of 3 and the remainder of 4 together to make a 7, such that it becomes divisible, right? And we also know that the sum of first 6 divided by 6 will have a remainder of 0, because it should be divisible. It should be divisible, right? So now it becomes, like a remainder problem. We just need to find a number that is divisible by 6 and has a remainder of 3 when divided by 7. And we know all the other numbers that have the same property by adding up the lowest common multiples of 6 and 7. So the first one is going to be 24. And after you add a bunch of 42s to it, it's still going to have the same property. It's still going to be divisible by 6, and it's still going to have a remainder of 3 when divided by 7. All right. So that's the expression of the sum of the first 6 numbers that I'm looking for. Okay. So now in this case, we're just going to tick it here. We're just going to tick it here. So 24 adding 42n is equal to, well, a certain sum. And you can just try to estimate the sum. We can see that it's 6 numbers between 91 and 100, right? Which means that it's at least 90 times 6. And then it's adding on the specific number. Let's say, let's call it C, all right? Because it's a constant. So we can call it C. So it means that 24 adding 42n is 90 times 6 adding C, which means 42n is going to be equal to 514 adding C. Now it means that 514 adding C is going to be divisible by 42. So let's just try to divide 514 by 42 first to see how many more numbers, how many more do we need to make a multiple of 42. So that's going to be a 1, so 42, having a 9 here, that's going to be a 4, so having a 2 there, that's going to be a... Where did 24 come from? Oh, 24 is the smallest number. Oh, that's not 514. That's 516, sorry. 24 is the smallest number that is divisible by 6 and has a remainder of 3 when divided by 7. All right. But that's not going to affect the... And C is just a random number. We don't know it yet. We don't know it yet. So we are yet to find out. Okay. Why 42? Because 42 is the lowest common multiple of 6 and 7. So that's the reason why when I add 42 to it, it has the same property, which is divisible by 6 and having a remainder of 3 when divided by 7. And no matter how many 42s I'm adding on top of that, it's still going to have the same property. All right. So we're just making sure that it has the same remainder property there. And well, now I see it has a remainder of 12. So if it has a remainder of 12, how many more do we need to make a multiple of 42? It's going to be 42 take away 12, which is 30. Right, so we know that C is 30. And we also can find the sum of the first 6 numbers by 90 times 6, adding 30. That's going to be 570. So, but then we need to find the score on the 6th test, right? Which means that we need to think again about the 5th test. So we know that after adding the first 5 test scores together, it's going to be a multiple of 5, right? And amazingly, after adding the score for the 6th test, it's 570, which is still a multiple of 5. So if you want to add something on top of a multiple of 5 to get another multiple of 5, what do you need to add? Does it have to be a multiple of 5 or does it not? So think about it. For example, 5. On top of 5, what do you need to add to get another multiple of 5? Yes, 5 maybe, or you can add 10, or you can add 20, but you can't add anything that is not a multiple of 5, right? So it means that if after adding the 6th score, it's still a multiple of 5, it means that the 6th score itself is a multiple of 5. So we have already taken 95 in one of the tests, which is the 7th. So for the 6th test, it must be the remaining multiple of 5 in the list, which is 100. So the answer is E, 100. Okay, So this is, again, a pretty much complicated question. So if we are, oh, I lost you, really? Where did I lose you? 100 comes from the list because it has to be between 91 and 100, right? And between 91 and 100, there are just two multiples of 5s, which are 95 and 100. Because 95 has already been taken on the 7th test. So the remaining one is 100. Yes, is a multiple of 5. That's right. And Sophia, where did you get lost? Is that also about this step? Or is that somewhere else? Before? How much before? You'd better tell me about it. Otherwise, I don't know how to help. That's because after that step. So that's quite early. That's because after each test, the average is an integer, right? Which means that it's divisible by the number of tests that it has taken. Yeah, why multiple of 5? That's because that's before the 6th score is added in, right? So after adding in the 6th score, we got 570, which is divisible by 6, yeah? But before adding in the 6th score, the first 5 scores must add up to a multiple of 5 because the average was an integer. So that's about the first 5 scores is a multiple of 5. And if you want to add a number on top of the multiple of 5 to get 570, then that number you need to add is definitely a multiple of 5. Otherwise, if you're just taking away any non-multiples of 5 from 570, it's not going to be a multiple of 5, right? So that's about the previous step. Okay. So that's a slightly complicated one. I think you really need to, drill your head in there to understand. So probably it takes some time. I'm just gonna, I'm just gonna move on to the next questions first, and then later I can just try to come back to this question and explain it to you, right? Just try to take some time to let it sink in if you do understand what the next questions are going on. All right, so for the next one, it's pretty simple, I should say. It's just about whether you can understand this expression, which means that 10, the exponent of 10, the exponential of 10 is going to be 10 multiplying, oh, not exponent, yes, you're right, factorial, sorry. Yep, so you have heard of it before. The factorial of 10 is going to be equal to 10 multiplying all the way to 1. So 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. And it says that, well, a unit of blood is donated at noon of January the 1st. So basically it's mixing a unit conversion with a date problem. So, well, you don't really need to know that. You just need to understand that a dot essentially means multiplication. And you're just multiplying all the way down to 1. Because the definition is given, right? So you don't really need to possess that knowledge before. So what you're doing is, first of all, you can try to write it out. 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And that's in seconds. But what the question is asking is on what day does his unit of blood expire. So we need to divide it by 60 times 60 times 24 to convert the seconds into days. So when I'm dividing it by 60, it becomes minutes. When I'm dividing the minutes by 60, it becomes the hours. And when I'm dividing the hours by 24, it becomes the days. Right? So that's where the 60, 60, and 24 comes from. For the first 60, it's easy. I will just take away the 6 and the 10 for the simplification, right? Or probably I should use another color to make it more significant. That's what we're going to do. And then for the second 60, well, it might take a little bit of time. We can have 5 times 4 times 3, right? That also makes 60. And for the 24, well, we can just simplify it with the 8 first, such that 8 becomes 1 and 24 becomes a 3. And then I can simplify the factor of 3 with the 9, such that the 9 becomes a 3 and the 3 becomes a 1. So what we have left are going to be 3, 7, and 2, which is 42. And it expires after 42 days. So we know that there are 30 days in January, which is 31 days in January, which is 30 extra days. In January. And 12 extra days in February. So it's going to be the 12th of February. All right, so it's just a simplification in fractions when you're trying to convert between different time units. And then you can see that it's going to be, well, a little bit combined to date problems as well. So once you get that, you should be all right. Date problems are not that hard. Okay, so that's it for the 5th question. And the 6th one. Okay, someone says it's hard. Sorry?
Could you quickly go back?
Okay.
Thank you.
Right. So for the 6th question, someone told me that it's hard. Well, it is not that easy in terms of, well, if you can understand what the question is saying. It says that every day for 4 days, Linda traveled for 1 hour. So that's the time, right? At a speed that resulted in her traveling 1 mile in an integer number of minutes. So what does it mean? Well, it means that if Linda can travel 1 mile in a certain number of minutes, then the speed of Linda per minute is going to be 1 mile divided by that number, right? By that integer. Yeah. So let's just try to move on and see what the question is asking. It says that each day after the first, her speed decreased such that the number of minutes to travel 1 mile increased by 5 minutes over the preceding day, which means that if on the first day, it takes X minutes for 1 mile, on the second day, it will be 5 more minutes, which is X adding 5 minutes for 1 mile. And on the third day, it's going to be X adding 10, which is 5 more minutes for 1 mile. And for the last day, the 4th day, it's going to be X adding 15 minutes for 1 mile. Now, it says that each of the 4 days her distance traveled was also an integer number of miles, which means that every day she's going to travel an integer number of miles. That's amazing. That's amazing. How is that even possible, you might think? So think about it. Every day she's traveling 1 hour, which is how many minutes? 60, yeah? 60 minutes. So if she's traveling an integer number of miles every day, it means that 60 has to be a multiple of x, a multiple of x adding 5, a multiple of x adding 10, and a multiple of x adding 15. Does it make sense? Because that's a whole number of mile, right? If every day is going to be a whole number of mile, it means that it's a few times of these x adding 5, 10, and 15s in order to get a whole number of miles. So let's just look through all the factor pairs of 60 to see if we can find anything in there. That's all. So the 4 minutes, like the 4 number of minutes every day, has a difference of 5 each day, right? So you just need to spot 4 of these factors of 60 that has a difference of 5 between each of them. Five, 10, 15, 20. So it means that on the first day, she would have traveled 20 miles because that's 12 miles because that's 60 divided by 5, right? So 12 miles on the first day. What about the second day? 6. The third day, 4. The fourth day, 3. So when you add these up, you get the answer C, 25. That's 12 adding 6, adding 4, adding 3. Okay, so basically the other side of the factor pairs. Does it make sense? Yeah, well, you can think about it as a ratio problem, which is like, so 12 is 60 divided by 5, because now that you can see x is 5, right? If you take 5, 10, 15, 20, you can see that x is 5. So 60 divided by 5 is 12. 60 divided by 10 is 6. 60 divided by 15 is 4. 60 divided by 20, that's 3. Okay. That's because, well, x adding 5, x adding 10, and x adding 15, the 4 numbers, they have a difference of 5 between each of them. So we also know that every day it's an integer number of miles, which means that these 4 minutes must be the factors of 60 minutes to be expended an integer number of times, right? So we just look through all the factors of 60 and find the 4 factors that has a very standard difference of 5 each time. Okay, so that's the 6th question. And wow, I'm just going to move on to the 7th one next. So this question is rather easy. It says that for those who are wearing sunglasses, no, for those who are wearing caps, the probability of choosing that person who is also wearing sunglasses is 2/5, which means that among the 35 people who are wearing caps, 2/5 of them, that's going to be 14, are also wearing sunglasses, which means that for all those 50 who are wearing sunglasses, there are 14 of them who are also wearing caps, because that's same both ways, right? That's the same both ways. So we know 14 people are wearing both caps and sunglasses. So if you want to pick someone who's wearing sunglasses at random and knowing the probability that this person is also wearing a cap, oh, does it not make sense? Because 35 are wearing caps. And among these 35, the fraction who are wearing sunglasses is 2/5, which means that there are 14 of them who are wearing sunglasses and caps at the same time, right? Sunglasses and caps, which means that the 14 of them are wearing sunglasses and caps at the same time, which means caps and sunglasses at the same time. It doesn't really matter which order I phrase it, right? It's still describing the same group of people. And in that case, I know that 14 altogether. Why is it 2/8? Where do you get the 8? That's a 5. That's a 5. That's a 5.
I think a teacher need to use a different.
So you misread the question. That's a 5, right? That's a 5, definitely. And well, so if 14 are wearing both, it means that among these 50 people, 14 are wearing caps. So the probability is just 14/50, which is 7/25. And it's going to be B. All right, pretty easy, this one. It's just worded a bit complicatedly. Oh, no. I didn't intend to write it like 8. So it's a 5 with the 5 simplified, okay? So that's simplified. Use different color. Yeah, good suggestion. I'll do that next time. But now I'm pretty sure it doesn't look like an 8. Okay, so that's it for question 7. And then for question 8. So this is pretty interesting, this one. So it says that there are 6 teams. Oops. There are 6 teams who are playing each other twice. You've done this before. Okay. So set a team earns 3 points for a win, 1 point for a draw, and 0 points for a loss. So after all these games have been played, it turns out that the top 3 teams earn the same number of total points. So what is the greatest possible number of total points for each of these top 3 teams? So basically, you can say that the top 3 teams are A, B, C. And the next 3 teams are loser, loser, loser. I don't care which loser they are, but they are all losers. All right. So if they want to get the greatest possible number of total points, well, let's imagine that they are all winning the last 3 teams in every game they have played. All right. So how many scores or how many points is that going to be in total? So each of the teams are playing against the loser teams twice each, which means that there will be 6 games altogether. And each of them is earning them 3 points. Right? So that's going to be 18 altogether. But after playing with the loser teams, they'll still need to play between themselves, right? So how could you maximize the number of points for 3 teams? Draw, really? Well, think about a draw. If I have a draw, then both sides are going to get 1 mark, right? Or 1 point. But if you have a win, one side is having 3 points while the other is 0. So if you add that up, you can see that a win-lose scenario is going to give you more total than a draw scenario, right? So naturally, how many games do these 3 teams have to play between themselves? 6. Yeah. Each team is playing 2 other teams twice. So altogether, 3 teams 6 times. So all you need to do is just to do 6 games, multiplying 3 scores for the total of each win, and then divided by 3 teams. So each team is getting 6 scores. So altogether, 18 adding 6, that's 24. All right. And well, if you don't believe me, we can just do this relationship, like win. So A is always winning B, B is always winning C, and C is always winning A. So each of them are going to get 6 points. Why divided by 3? Because there are 3 teams. There are 3 teams. Which part have you missed? So first of all, they are all playing against the loser teams. Nah, there are 3 teams. So there are 3 teams and they are playing 6 games. They're playing 6 games because each of them are playing each other twice. Each other twice. Okay. So A and B are playing twice, B and C are playing twice, C and A are playing twice. So altogether, there are 6 games. And we know that a win-lose scenario is going to give us more total than a draw scenario. So the win-lose scenario is giving us a total of 3. I'm just considering this as 2 different cases, like 2 different parts. No. Altogether, it's not, definitely. So like for the 3 winning teams, let's assume that they are all winning against the loser teams, which means that they would have won twice for each loser team. And there are 3 loser teams together. So altogether, they will have won 6 matches each against the loser teams, which makes 18 points. And then among themselves, they are playing 6 games, which each of them will have 3 points if you want to maximize the points. So there will be 18 points altogether for the top 3 teams' games. And 18 points altogether split it evenly among 3 teams. So you're going to get a 6. Well, you don't understand? Which part of it do you not understand? I think probably an alternative is to, like really try to figure out how these 3 teams can play amongst themselves. So like, you do understand that these 3 teams are playing 6 games altogether, right? But if they are drawing, they will just have a total of 12 scores. Yeah, and like if one of them is winning and one of them is not, oh, you know now? Okay. Yeah, probably it's just gonna need some time to sink in, as I said. For these a little bit more, you know, like mind-teasing questions. Okay, so for the next question, I'm pretty sure I got something wrong in there. So the original number should be a quarter, but if it is just like that, the answer should be C. All right. So I'm not explaining it any further because this is a wrong question that I used. So my apologies. My apologies. This is a wrong question. All right. And for the last one. So the last one is, well, not too difficult, I would say. It just says that a scientist walking through a forest recording as integers the height of 5 trees standing in a row. So it means that the height of 5 trees has to be an integer. All right. And she observed that each tree was either twice as tall or half as tall as the one to its right. So it means that every 2 neighboring trees is going to have a multiple relationship of 2. Either one of them is twice the other, or the other one is twice the first one. All right. So every 2 trees are going to have a multiple relationship of 2. And it says that some data were lost, blah, blah, blah. And finally, she got the average height of something 0.2 meters. All right, so this 0.2 is very suspicious. It basically means that if the average height of 5 integers is something 0.2, after multiplying 5, you're going to see that it's going to have a remainder of 1. Like the total is going to have a remainder of 1 when divided by 5. That's the only way you can get a 0.2, right? So it means that the height of the 5 trees is going to end up either with a 1 or with a 6. That's how you can get a remainder of 1 when divided by 5, right? So it's going to be having a remainder of 1 when dividing by 5, which means ending with 1 or 6 for the total. All right. And now, also, we know that they are all integers, right? So what can you put next to 11? If it needs to be either half or double of 11, and it needs to be an integer, can you do half of 11? Because we know that the neighboring trees are either twice as tall or half as tall, right? So can we do half of 11? No. So the only thing we can do is 22 and 22 right there. So now I have 55 in the first 3 trees. Do you think another 2 numbers is going to give me something ending with 1? Say, for example, we have 11 or 121. Or tell me. Probably. Well, definitely not 11, but it can be 121, right? It can be 121. So let's say 121 take away 55, because we can see that the reason why it's 121 is because it has to be a multiple of 11. Yeah. 11 is a prime number and it's the smallest number possible, which means that all the other numbers should be multiples of 11. So 121 take away 55 is going to be 66, which means that the next two numbers are going to add up to 66. So what about the next number? What can you do for 3, 4? Yeah, it's either going to be 11 or it's going to be 44, right? But if it is 11, then the 3, 5 must be 22, which is not making up to 121. If it is 44, the next one can be 22. So it is a multiple, it makes up to 66, which gives us 121. So 121 divided by 5, that's 24.2. So the answer is B. All right, where does 121 come from? So that's an interesting story. First of all, with the 0.2, I know that the total must end with 106 because 0.2 indicates a remainder of 1 when divided by 5, right? And then for the first three trees, we can see that it's going to add up to 55. So, well, it can hardly be 66 because another 11 is going to make 66, which means that it has to be the next multiple of 11 ending with a 1. It's going to be the next multiple of 11 ending with a 1. That's going to be 121, which is 11 times 11. Right? Okay, so I'm just going to go back to 1 and 2. What do you mean never did it before? Like these kinds of questions? Or like 1 and 2? All right. So can you see my mouse actually? Just that I'm not destroying any. Ah, I see. So you haven't done any competitions before? No? Okay, okay. So this question can be solved using a Venn diagram. So basically, all we need to know is that, well, in a Venn diagram of 3 objects, we can consider it as 3 different parts, okay? So the first part is that, well, this is going to be counted once for these peripherals, right? And for these petals, they are counted twice repeatedly because they are overlapping for two circles. Well, I'll get there. And in the middle, it's going to be a 3 time because like all 3 of the circles are overlapping in the center. How long will you get on the test? You mean like the test for Sunday? Ah, so you're going to have 1 hour. You're going to have 1 hour. Yes, we'll do. The answer for question 7. Let me see. Is that question 7? Or is that? That's question 7. B. The answer is B. We'll have 20 questions altogether. So 15 of them will be multiple choices, and 5 of them will be filling in the blanks. So yeah, it requires you to work pretty fast. But of course, you don't need to answer all of them. I would say that, yes, I will. I will do it on Monday. I will go through the whole paper on Monday. Okay. What time? Good question. I haven't set the time yet. So probably still the same time, 7 p.m. That's all right. I'm just going to have the playbacks. Don't worry. So for whoever's done today, thank you for coming. And if you have any further questions, you can stay a little bit longer and I'll try to help you as much as I can. All right. Okay, bye-bye. All right, so back to this question, back to the first question. So what we have is a small Venn diagram right there. So basically what I'm trying to say is that, well, for the three petals, they are counted twice each. And for the center, it's counted 3 times, right? So that's the main idea of this problem. So now we are just thinking about the 3 days, 4 days, and the 5 days as, you know, like the numbers that are going into these circles, which means that how many days are there that's divisible by 3 are there in 365 days, like from 1 to 365. How many days are divisible by 3? So that's what we have, 121. How many days are divisible by 4? 91. And how many days are divisible by 5? 73. Which means that if I have the 3 circles overlapping, definitely we can't just add them up, right? Because adding them up will mean that I'm having more days than I should, as some of them are repeatedly counted. Some of them are repeatedly counted. So that's the reason why we want to take away the repeated bits by removing these 3 rugby shapes, like these rugby shapes, including the side and the middle, right? Including the side and the middle. So that's a rugby shape. We are removing these 3 rugby shapes from the whole thing. And each rugby represents the overlapping part between 3 and 5, 3 and 4, and 4 and 5, right? So it means that it needs to be divisible by both 3 and 5, 3 and 4, 4 and 5. So that's how many numbers there are among 365 days, 24, 30, and 18. All right. But the thing is that after I've taken away all these 3 rugby shapes, you can see that the middle part has been taken away 3 times, which originally it has been counted 3 times, but now it has been taken away 3 times, which means that the middle part is going to be empty now. There's nothing covering the middle part. So we need to put the middle part back into that number by finding how many numbers is divisible by 3, 4, 5 at the same time. That's going to be 6 numbers. All right, so the whole process is adding up the green numbers, 121, 91, 73, taking away the rugby shapes, taking away 24, taking away 30, taking away 18, and finally putting back the center bit, which is 6. All right. And what you get will be the number of days that Mrs. Sanders got called. But it says that how many days did she not receive in this question? So you should do 365 take away 219 to get 146. All right. So that's how we managed to solve this question. Does it make sense? So that's for the first one. And I heard someone asking about the second one. So the second one is pretty interesting. You just treat the 5 seats as 5 numbers, right? Which means that if all the 5 friends are taking the number on their seat and adding it up, it's always going to be 15. Does it make sense? And when B had moved 2 seats to the right. It means that the number will go up by 2 for B. Yeah. And when C is moving 1 seat to the left, it means that the number will go down by 1. But in the end, all the numbers of the 5 people are going to add up to 15, right? And we know 15 adding 2 take away 1 is 16. So what's the move for adder? It must be taking away 1, which means moving 1 seat to the left. And finally, after moving 1 seat to the left, adder is going to have the end seat. So when you move 1 seat to the left, can you get the rightmost seat? No, that's impossible, right? It must be the leftmost seat. So it means that adder will be ending up with seat 1, which means that before she got up, she's 1 seat to the right of seat 1, which is seat 2. So that's how we know that adder has been sitting in seat 2 before. Okay. And did someone say question 7, or are you okay now? Any other questions from anyone? Like which question did you find hard? Which question did you not understand? Just let me know. No? All right, then. If that's the case, then I'm just gonna call it a day. All right. I know it's pretty late now and it's Friday evening, so probably you're gonna have dinner or have some family time, whatever. But yeah, that's it for the day. No problem at all. Thank you. Thank you all for coming. And well, good luck on Sunday. All right. Good luck on Sunday. What I want you to know is that, well, don't worry too much about the results. All I want you to do is to be your best self, like getting your everything in there and trying to learn something, all right? As long as you have learned something from these sessions or like the competition itself, the test itself, then, well, you have already improved yourself and you're becoming a better self. So don't worry about it at all. Like those questions tend to be hard. They tend to be hard. And I just hope that you will be all fine to accept the challenge and working even harder if you're not satisfied with your own outcomes or whatever. And don't be too proud if you're satisfied with your outcome. So just try to be, you know, like consistent with your work at all times. Okay. That's what I want from you. All right. That's going to be the end of the lesson today. Thank you. Thank you for coming and have a nice day to you too, Sophia. Thank you. Leo, have you got any questions for me? Or Sophia, have you got any questions for me? No? All right, then I will see you next time. Bye-bye.